So we start with the horizon line, we select a vanishing point, and then we continue with a scale figure. Okay? That scale figure needs a friend. That friend is going to be standing on their shoulders. They're at Coachella. It's day 3 of Coachella. Okay, the weekend is opening for 1975. They're standing on each other's shoulders. Okay. 1975 played here. Emmons Auditorium back when we had live music. Remember that? Those were the days, man. Okay? So from bottom of foot to our friend's eye level, how tall do you think that is, roughly? 12 feet. 11, 12 foot. We'll call that 10. Okay. Some of you are taller than me, but we're going to call that round about 10 feet. That's a 10-foot height, relative. Okay. And then I'm going to create a vanishing line from the foot to the vanishing point, and from the head. The sound of rulers hitting the concrete in the morning sounds like victory. Okay, that's our first vanishing line. This is how we can set up any street level perspective that we want. Next, I have to make an unscientific guess. This is the most unscientific part of the exercise. We have to make a depth guess. Based on the perception of our two scale figures, we have to make a guess of how far we think a 10-foot ball might go. This is an unscientific thing. It is done with practice. You just have to make your best guess as to how far you think 10 feet is. We call that the depth guess. 10-foot depth guess. This depth guess will set up the rest of the drawing. It's critical because it sets up the future of the rest of the drawing. Okay. If we go from the top of this corner through this midpoint and down the diagonal, we are able to project the next 10 feet. Then we can draft that next 10-foot wall. That's the next 10 feet going forward. I can do it again. I go from here through this midpoint, down, I get the next 10 feet. And the next 10 feet. And oh yes, the next 10 feet. Oh, maybe the next 10 feet. What's happening to these lines now? Getting closer. They're getting closer together, right? But they are demonstrating a sense of depth. Because they're getting closer together, it's giving us the perception that we are looking out into space. Okay. I can even project forward and do the next 10 feet in front of our two friends. Do the same thing, same principle. Go from this corner to that midpoint. I can project the next 10 feet going forward. It's kind of exciting. They both fall down flat, perfectly flat. Thud. They've had a terrible accident. got dehydrated, something like that. It's the third day of Coachella. Oh, so you fall down flat. Okay, so that's the next 10 feet on the ground plane. So you can measure that, repeat it if necessary. It's about 2 3/4 inches for me, so I'll just make that the next 10 feet. Two 3/4 inches represents the next 10 feet. So in effect, we are building a grid. And then we have these reference points here, 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 and here, in which we can then roll this up and lay out the rest of this floor grid. And the tiles of this floor are starting to get closer together as well. Okay. So it's from there, any person who is in space now, if they are walking, they're going to be at eye level with us. We are the viewer anywhere they might be on this ground plane. If their eye level is at the horizon line, we can start to use people to represent a sense of depth. And we can put any figure that we want in here by doubling, tripling, or otherwise in a 5-foot or 10-foot increment. We can start to put things into space here. Imagine things relative to these measurements. Imagine spaces. Imagine trees. Imagine floor planes, seats, planters, any sorts of variety of things that we want to once we have that thing set up. Okay? Relative to that 1-point perspective, this needs to vanish to that vanishing point like so. These two sides are parallel. So that's better, Lauren. Okay. So that's a review of the Lockard method of 1-point perspective. This was touched on in Craig's video. It's also in my video. I have a 20-minute version of this posted now. This was part of Craig's video as well. This notion of setting up a 1-point perspective from a human scale figure, and then being able to start to imagine increments of space going backward and to the side, and starting to imagine this as a floor plane and this as a wall surface that is successively going further and further back into space. But it's a helpful starting point for setting up a 1-point perspective for any type of scene that you may be interested in, particularly if you have abilities and interest to actually start to design in perspective. If you have that and you're able to master this, it can be quite liberating because it allows you to start to think about space and experiences from a human experience viewpoint, not just from plan or section, but from starting to design experiences right in perspective and then start to set things up from there. So the ability to design in perspective can be quite liberating, because it gives you the freedom then to start to think about human experiences from eye level, not just plan or section, or whichever software you're using. Okay. So that's a review of 1 point. Are we ready to tackle 2 point? 2 point is a variation of the same method, so it was important to review that original method. With the 2 point perspective method, we began as we would with the 1 point perspective method by beginning by determining the horizon line. Everything originates from the horizon line. Where we place the horizon line on the paper will start to determine the character of the drawing. It's one of several variables that will determine the character of this drawing. I will now place 2 vanishing points as opposed to 1. 2 vanishing points on opposite ends of the paper. Where we place the vanishing points also determines the character of the drawing, although they will always be on the horizon line. Third, I will, just as I did with the 1 point perspective, I will start to include a notion of human scale. Their eye level is on the horizon line. This person will have a buddy as well, standing on their shoulders, representing a nominal dimension of approximately 10 feet. So this is our reference to real scale and human scale. Everything that contacts this line, I call it the measuring line, or ML, has references or representation of a total of 10 feet. Just as we do in the 1 point perspective method, I will now take a vanishing line to the vanishing point, vanishing line to the left vanishing point, and vanishing lines to the right vanishing point. Being careful that they are correctly aligned to the vanishing point. Made a little mistake right there, but I will correct that. Okay, very similar to the 1 point perspective method, we need to determine a 10-foot depth guess. So if our 2 figures are standing next to a 10-foot wall, we need to determine how deep or how far that 10-foot depth guess can occur. So I will shade that here with a little bit of colored pencil just to fill that in for the left vanishing point. This is our 10-foot depth guess. And also for our right vanishing point. Now, if we started to imagine this as a cube of space or a cube volume, then the character of our 10-foot depth guess might not be exactly the same. We can see that relationship of this cube to our left vanishing point is different than the relationship to its right vanishing point. So chances are we're going to see more of this right-hand side of the cube. So my depth guess is going to be a little bit different on this side. So my 10-foot depth guess is here. I'll fill that in with some colored pencil. Just as we did with our previous method, the way that we project the next 10 feet in space, we go from the top of this through the midpoint and then down to the base plane like so. Very similar to how we did it with 1 point perspective. So that represents now the next 10 feet. So that represents the next 10 feet. If this is a 10-foot depth guess, then this represents the next 10 feet. Similar to our previous processes, we go from here through this midpoint, that represents the next 10 feet. Here to here represents the next 10 feet. And so on. So from here to here represents the next 10 feet.
here to here represents the next 10 feet. Here to here represents the next 10 feet. You get the idea. All of those representations can also be transferred to the floor plane. However, the portions of the floor plane are going to be vanishing to the left vanishing point, so I can actually project the floor plane now. Using that left vanishing point, we can start to measure out distances on the floor plate relative to the left vanishing point. So now we're starting to get an idea of space, depth, and dimension, like so. Our two friends are getting tired, and so they end up falling directly clunk, like so. So this representation of measurement can be transferred down. I can see that that's approximately just under 2 inches. So if we were to imagine them falling and laying on the ground perfectly, this is approximately just under 2 inches. So that represents 10 feet on the floor plane. That will now vanish to the right. So that's the beginning of perhaps a footpath width, or alley width, or street width, something of that nature. Same thing goes for perhaps street width over here on the left. If we were to imagine our two friends falling down, clunk, onto the ground, I measure their height of 10 feet. It's just under 2 inches for me. It's just under 2 inches for me, so I will translate that measurement over to here. Here's our two friends laying on the ground. They've been standing next to our wall, but they do fall down. That represents 10 feet of space here on the floor plate. I will translate these projections just as we did for the other. Okay. Running out of space here. All right. So we have representations of 10 feet in depth vanishing to the left vanishing point, 10 feet in depth vanishing to the right vanishing point. We can also project up. Anything contacting this measuring line can be translated up. Just in terms of measuring it, again, I'm just under 2 inches, so I'll just repeat that measurement, like so. That'll give me the next 10 feet of space. I also could look at the midpoint of this line, of this depth guess line, and project that up to create the next 10 feet. Same theory that we use to project backward, we can use to project up. So if this is the midpoint of the depth guess line, I can go from this corner through that midpoint and project up the next 10 feet. That will vanish to the right vanishing point. This will vanish to the left vanishing point. And we can now imagine another cube stacked on top of our original cube. This is another 10 foot by 10 foot cube stacked on top of our other cube, like so. I can do that again. I can do that again if I have a midpoint of this depth guess and I go from this corner through there. I can project the next 10 feet. This represents now 3 10 foot by 10 foot cubes. Standing on top of each other. now 3 10-foot by 10-foot cubes stacked on top of each other. Naturally now, we can vanish and create further walls or further projections of space towards our right vanishing point and our left vanishing point. And we can start to imagine this as a piece of architecture or a corner situation in an urban context. Perhaps there are people or places starting to develop now, scale figures that have their eye level at level with us, no matter where they are in space. If they are standing people and we are a standing person, then their eye level will be similar. So we can even start to imagine this as an urban scene. Perhaps 2 sidewalks wrapped around a corner building. Their heads will be, no matter where they are in depth, will be at eye level, like so. We can start to imagine this maybe perhaps as a building facade. We can start to imagine this as a construct of different cube volumes. We can really start to create some interesting scenarios for us. We can also imagine that this is a path for a ball to travel through for the purposes of our project. If this is the general path of the ball, then we can start to build our perspective grid to represent all the different towers, ramps, staircases, or features that the ball will travel through. And start to imagine that as a representation of our studio project. All of the planes and spaces and support armatures and walls, all those things that now vanish to the right vanishing point and to the left vanishing point. This can really start to take shape. And there might be representations of shade and shadow that start to occur. There may be representations of solid and void that start to occur. We can look at our model and start to sketch it into this perspective framework. Let's maybe start to see it now. Lots of opportunities for us to reference once we have a right vanishing point and a left vanishing point. Perhaps this then begins to become a representation of our circulation project. Everything makes reference to either the right vanishing point or the left vanishing point, like so. Always use that right vanishing point and that left vanishing point to help us begin to see different spaces, different ramps, different pathways, different planes. Once we have those right and left vanishing points, as Bob Ross would say, there. So as we look at our model and we translate our verbs into diagrams or into actions or ball movement, features, spatial features, these different parts of Ping and Bing's journey, maybe different structural elements, maybe we have some columns in the form of dowel rod or shim strips supporting different elements. Start to sketch those in once we know and have reference to our right vanishing point and left vanishing points. A little bit of shade and shadow, and that's starting to look like something. Maybe there's an exit point, entry point. Maybe this is part of the foam model now, happening down here. Different passages, doorways, thresholds. And that all starts to fill in. Openings, ramps, and exits. Okay, so this takes us through the basic steps of setting up the two-point perspective and then starting to imagine our ping and bing parkour adventure being placed into this two-dimensional perspective setup, and then visualizing and imagining all of those masses and voids in perspective. Take a couple of photographs of your model in the light and start to really place the major shade and shadow features, regions of the model. Okay, thank you very much.